right. Quadrilaterals. Oh, sounds like something. Nah. Quadrilateral, just 4 sides. That's all. 4 sides. So right here, we're just going to do one problem. But within that one problem, we're going to get a few different shapes. I should even do a little triangle review within this. So in our course, you generally do not get, like in math class, here's a shape, find the area. Usually, it's dressed up in a graphing problem like you see here. So this gray shape down here, you may be asked to find the area of that shape. Well, that's not too hard a thing to do. There's a couple ways to go about it. By the way, a few quadrilateral formulas over here on the side. Rectangle is just base times height, or square. Parallelogram, base times perpendicular height, and trapezoid. And so actually the shape you see here, you might need to turn your head, but this is a trapezoid. Trapezoid has minimally one pair of opposite sides that are parallel. So this bottom side, which we call base 1, and this top side here, which we call base 2, those are parallel. Other than that, there's not much in the way of symmetries here. You see a right angle, maybe you call this a right trapezoid, but yeah, it is a trapezoid right here. Okay, so before we jump into the trapezoid formula, we break this down in a way that you may do this just because it's easier based on what you already know. So one thing you can do is break a shape into multiple shapes. It's a compound shape. Actually, you can see here on the left, we have a triangle. On the right, we have a rectangle. This one clearly doesn't look like a square, but beware, these are generally not squares because the base and the height, regardless of whether the same number of boxes, the numbers come from the axes. And so in this case, the axes don't match. So this is not a square anyway. It can't be a square. Okay, meaning these two sides, these two lengths, they can't be the same. So if you needed to find the area of the entire shape, area of the entire trapezoid, let's make a little trapezoid symbol down here. One way to go about this, we're really going to split this. We're going to look at this 2 different ways. One way to go about this is actually take the area of the triangle and sum that with the area of the rectangle. Now, this is based on equations or formulas you already know how to do. The other way is with the trapezoid formula, and we'll come back and look at that in a moment. So if we're going to do it this way, it's not too tricky. So the area of the triangle, well, you can set them up. You can do the full Gibbons format. Step 1, you have a base of here. It starts at 0 and it ends at 6. So the base is actually from 0 to 6. It's 6, and this is representative of time. So that's actually going to be 6 seconds. I know that seems a little funny, but yes, this is a representative area here. This is not a physical area, meaning you're not going to take a ruler or a meter stick and put it along the bottom of this and see how long it is. You're actually going to read it off the axis. And so that axis is for time. So the base of this triangle is actually a time, 6 seconds. The height of the triangle, when you do an area, the height always has to be perpendicular to the base. In this case, it is. Nice, easy triangle. The height of this one, 3 blocks, represents 15 meters per second. 15 meters per second. Okay, so this one is not meters either. And so you need to find that area of that triangle, question mark. Now, I'm not going to put a unit on that yet because that might be a little confusing. And truthfully, the purpose of this lesson is not the units, just for you to do the areas. So, of course, your equation, area is 1/2 base times height. Slip that in over here. And then we can run our numbers. And doing that, I'm sure you're running ahead of me at this point, which is a good thing. 1/2. I'm going to put the units in there for you just to introduce you to it. We're not going to lose our minds over those units just yet. So base 6.0, and I'll color code them here. And the height is 15. And let me color code these with the green. So this is seconds, and this is meters per second, m/s. Don't write this slash nonsense like you see up here. Write m/s. That's the correct way to think about these. Okay, and so then when you do this, 1/2 of 6 times 15, so I'll apply the half to the 6, that's 3. 3 times 15 is 45. Okay, so the area of this shape, this triangle, is 45. Now for the moment, if you just know 45 and you're not sure what to put for the unit, I'm not that concerned. However, what you can see here is that the seconds in the numerator and the seconds in the denominator will cancel. And this area actually has a unit of meters. That's because this is a representative area. This is not an actual physical area. You're pulling this from a graph. So here in the previous lesson, if you watched it, we did something on circles. They actually said the circle had a radius of 1.2 meters. That's an actual physical distance. That's a true physical circle, or at least it's drawn as one. Okay, let's do the rectangle. So the rectangle, same game, base. Now be careful here. The base is not, you may go up and look and say, oh, it's 10. No, it's not. It started at 6 and it ended at 10. So the base here is actually 4. And same unit, seconds. The height of this rectangle is the same as the height of the triangle. That was at 15 meters per second. And for a rectangle, you were just doing area equals base times height. Okay, step 2, plug it in. So even easier than the last one. Effectively, we're doing the same problem, except now our base is 4. I'll leave the space out for the unit for the moment. And the height is also 15, like last time. And so if you run your units in here, this is 4 seconds. And this is 15 meters per second. And then your answer comes out to 4 times 15 is 60. 2 sig figs. Put a dot there to ensure that. And the seconds, numerator and denominator cancel, and this is left in meters. And it should be because you need to add these two together. So you can't add different units together. So finally, the area of the trapezoid is 45 meters. And there's a little struggle. Plus 60 meters. And of course, your answer comes out to 105 meters. Now, if you remember with addition, the rule was the fewest number of sig figs after the decimal. So this has none, this has none, this has none. Good, we're done. All right. Now, just in case you like the formula for area of a trapezoid, you could do this entire area at once. Here's how it goes. So our step 1 over here is we now have 2 bases. Base 1, we can make the bottom. That's from 0 to 10 seconds. So why not do this one in purple? Okay, base 1 is from 0 all the way out to 10. So that is 10 seconds. Base 2 is parallel to base 1, the opposite side over here. That's from 6 seconds to 10 seconds. So base 2 is going to be 4 seconds. And then you're going to need a height. And the height has to be perpendicular here. And so the height in this case is the same as the height for the previous part. Starting at 0, you're going up to 15, or the previous treatment. So that's just 15 meters per second. Okay. Now, the formula for the area of a trapezoid, you do not have to memorize this. You can always break it into triangles and rectangles. However, it's not a bad formula. In fact, if you realize what you're doing, it's quadrilateral, so it's base times height. Primarily, it's a base times height problem. However, there are 2 different bases. There's a long base and a short base. So take the average of the bases. So I'm going to write it a little differently than what you see up here. The average of the bases means add them up and divide by 2. So base 1 plus base 2, that whole thing divided by 2. So average the bases, it's really the nicest way to think about it, times the height, and you will get your area of the trapezoid. So step 2, plug it in. Area is, base 1 is 10 seconds, base 2 is 4 seconds. Add them up and divide by 2. So that's not too hard. 10 plus 4 is going to give you 14. 14 divided by 2 is 7. So we have 7 times 15 in meters per second. Now, you probably, based on before, recognize what's going to happen with those units. But basically, 7 times 15, well, 7 times 10 is 70. 7 times 5 is 35. 70 and 35 is 105. And the same thing happens with the units. The seconds up here cancel with the seconds down here, and you're left with meters. Done. Same exact answer, as of course it had to be. If you don't know, you know.